In this lesson, we're going to learn about the remainder theorem. Now, you've actually kind of learned this already. The remainder theorem says, hey, if a polynomial p of x is divided by x minus c, then the remainder is whatever p evaluated at c is. So basically it's saying, in other words, the remainder is the same result you get from synthetically dividing as if you were to just substitute c in. So basically what we can say here is to find the following f of 1, f of negative 2, we can do that two different ways. We can either substitute or synthetically divide. So you can either use substitution or synthetic division. And when you synthetically divide, it's the remainder that we're looking for. So we're looking for that remainder. So let's show this two different ways, which your homework will ask you to do. So f of 1, that just means plug it in. 1 cubed minus 7 times 1 plus 3. Well, that's 1 minus 7 plus 3. So 1 minus 7, negative 6. And then I'm still adding 3, so equals negative 3. So that's one way. The second way is, hey, take 1 and let's synthetically divide. So that was route 1. Now let's show synthetic division. So going back to our original function, we got to make sure there's no missing terms. X squared is actually missing. So let's rewrite this as x cubed, 1x, plus 0x squared minus 7x plus 3. So I know I need 1, 0, negative 7, and 3. Bring down the 1. 1 times 1 is 1. Add 1 times 1 is 1. Negative 6. And we get negative 6, negative 3. And then notice how our answers here both match. We got negative 3 by substituting, and we got negative 3 by synthetically dividing. Alright, so let's go and do f of negative 2. Same exact thing, put negative 2 in. So negative 2, don't forget the parentheses. Minus 7 times negative 2 plus 3. Negative 2 to the third power is negative 8. Again, you don't want to forget those parentheses if you're using your calculator. Negative times a negative gives me a positive 14 plus 3. So now I get negative 8 plus 14. That's 6 plus 3, which ends up getting me 9. So again, let's go ahead and synthetically divide. So take negative 2, and same coefficients, 1, 0, negative 7, 3. Bring down the 1, multiply, negative 2, add, negative 2, multiply, positive 4. Negative 3, negative times a negative gives us 6, and we get 9. So again, our answers match. That's how you would show it on your homework. So, another thing is we can determine if something is a 0 of a polynomial, which we've kind of already done using the factor theorem. Is it a factor or not? The big goal here is, hey, use synthetic division. If the remainder is 0, then yes, it is a 0. So it is a 0 / solution. If the remainder is not 0, then it is not a 0 or solution. Sorry, there you go. So again, basically all we're doing here is synthetically dividing and determining is it a solution or not. So take 2, look at our polynomial, we've got x squared, x, negative 6. So take 1, negative 1, and negative 6. Bring down 1, multiply, you get 2. Add together, you get 1 again. Multiply, you get 2. Add together, negative 4. Now, negative 4 does not equal 0, so 2 is not a solution to p of x. So again, same thing here. Take -1, we're going to synthetically divide here. We got cubed, squared, linear, constant. Nothing's missing. 1, 2, 3, 2. Negative, we bring down 1, we get -1. Add them together, get 1, multiply -1. Get 2, multiply -2, add together 0. 0 equals 0, therefore, -1 is a solution. So we got one example where it's not, remainder is not 0. One example where remainder is 0, so it is a solution. Alright, so now we're going to talk about one of the biggest theorems in algebra here, and that's the fundamental theorem of algebra. The fundamental theorem of algebra states that if f of x is a polynomial of degree greater than 0, it will at least have one 0. So basically it's saying, hey, if f of x is a polynomial of degree greater than 0, then it will have at least one 0, or solution, or root. So basically what it's saying is, hey, the degree of the polynomial indicates how many there will be, how many zeros there will be. And zeros may be real or imaginary. So basically, what we're going to do is now we're going to actually solve these polynomials that we've been using. We're going to find every single answer to the polynomial. So solving, we can use different things we had from first semester and from previous courses. So we can factor. Remember, that's where grouping comes in. We can use difference of squares. So it's like x squared minus 9 or x squared plus 9, that kind of thing. Sum and difference of cubes, we actually did not talk about this year, so you're not going to have to worry too much about those. Grouping, again, that goes with that factoring. So anytime you have 4 terms, you might want to do that. Guess and check, another big one is the quadratic formula. Roots, that's saying, hey, that even root property, so like taking the square root of both sides. So when the examples say find all real and imaginary zeros, that means that you need to go ahead and factor, group, perfect squares, all that fun stuff. So here, I've got a quadratic. So what I would want to do first is say, hey, can I factor this? Well, hey, I need to multiply to get 12. I need to add to get 8 in the middle. And I can do this because there's no a out front. A is 1. So this is easy to factor. So think of two numbers. Well, right away I'm saying, hey, 2 and 6. So why don't we try 2 and 6? So x plus 2 and x plus 6. Now again, if you need to do that check step, do the middle, you get 2x. Do the outside, we get 6x. Add together, you get 8x. So we're good. We matched what the polynomial is. Now don't forget that this is still equal to 0. Now, since it said find them, you need to set those equal to 0 and solve. So x plus 2 equals 0, and x plus 6 equals 0. So subtract 2, x equals -2. Subtract 6, x equals -6. Now, what was the degree here? The degree was 2. So degree is 2. How do I know that? It's the highest exponent. So that means I should have 2 solutions. I have 2 solutions in the end. So let's use the same logic here. What's the degree? Highest power is 2, so this is degree 2. So 2 solutions. Now, I want to set this equal to 0 first so I can actually solve it. Here's where you should realize, oh hey, I'm missing a middle term. So then what you can do is you can actually use the even root property. Subtract 36, subtract 36. We want to get the x squared alone. Now, this is where it gets a little bit tricky. It's like, hey, what do I do from this point? Well, what you want to try to do here is you want to try and square root to get rid of the squared. Now remember, anytime you have a negative square root, that's where I comes in. So square root, negative number, use I. So we're going to take I out of this, so it becomes I square root 36 equals, plus or minus, don't forget that, x. Well, what is the square root of 36? It's 6. So we get x equals plus or minus 6i. And we have two solutions there. So we're done. We found all the solutions. Alright, so this next one down here, this actually ends up being a difference of cubes, which you haven't learned in this course. So what I'm going to do is I'm going to switch this problem. I'm going to factor it for you. So we're going to have x plus 3, and we're going to do x squared minus 3x plus 9 equal to 0. So this one's already in factored form. So set this equal to 0, x plus 3 equals 0. So x is going to equal negative 3. Now remember, the degree here is 3. So degree is 3, which means 3 solutions, real or imaginary. Now, I want to go ahead and I need to factor this one. Well, can I think of two numbers that multiply to get 9 but add to 3? I'm kind of racking my brain saying, hey, can I? No, I can't think of any. Now remember, you can use that b squared minus 4ac to figure that out. So let's go ahead and actually use the quadratic formula. So that x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So here we've got a, which is 1. We've got b equal to negative 3, and c equals 9. So x equals the opposite of b, so 3, plus or minus negative 3 squared minus 4 times 1 times 9 all over 2 times 1, which is just 2. So now I've got x. Let's simplify some things. Plus or minus 9 minus 36 all over 2. So I've got x equals 3 plus or minus the square root of negative 27 all over 2. Now again, that's where you're saying, hey, I got a negative number, so I need an I. This also happens to be 9 times 3. So we've got 9 times 3, so I can pull out a 3. So simplifying this, I'm going to move over into this space here. I get x equals 3 plus or minus 3i square root 3 over 2. Now if this could reduce, I would go even further. That plus or minus tells me I have two solutions here. So I've got two solutions, and I had one solution over here, which equals my total of 3 solutions I need in the end. Now, I'm only going to talk about how to kind of factor this one in the beginning. Remember, if you have 3 terms, that's where you might want to try something by grouping. So I'm going to move 4 down here. X to the 4th plus 4x cubed plus x plus 4. 4 terms, you should look to see, hey, can I take out anything from them? Well, here I see cubed and 4th. I could probably take a cubed out. X, well then there's one x left plus 4. Well, hey, that's x plus 4 there. So do 1 x plus 4. And that's how I would start the grouping here. Now factor out your x plus 4. So x plus 4, and then left with x cubed plus 1. And then, of course, equal to 0 because I'm solving. Now, I'm not going to complete this one because, again, this is another difference of cubes, which we're not going to ask you to do. All the ones in your homework should be not cubes and stuff like that. It should come out nicely to factor into squares or such. So you would get x equals -4. This would have to factor further. Alright? So now what I want you to do is I want you to try these examples on your own. So this is saying, hey, use 2 different methods to solve these, so synthetic and substitution. And then find all the zeros of the function. That's like what we just did. And bring that to class tomorrow to discuss.